Hi, hello. We're presenting our NASA Mars Lander final report for our first year engineering lab of section 8. We are section 8 and for spring 2024. In the next slide, you can see the next overview of our items list and we'll be pretty much just talking about here. We're going to be doing some introductions of both myself and the team. We're going to have some background information, requirements, final designs, and obviously it'll end in our test results. So if you could please move on to the introductions. And so here in our team, we have um, we have myself, the project manager, Thiago Noah. We have Logan Stroud, who is one of our construction managers and test managers for this experiment. We also have Matthew Brunelli. He is one of our construction managers as well, and Julian Barrios, who is another construction managers and analysis. So it's reached out by a contractor in order to deliver a space shuttle that is capable of delivering again two astronauts to the surface of Mars. It must also, this is the last final proposal for our contractor, which is a 15-minute video proposing all of the engineering and overall the steps that we took to complete our space shuttle. If you look to the next slide, you're going to see that they gave us a contractor summary of what they wanted the space shuttle to do minimum, which was obviously the space lander itself had to be both reusable and it had to carry at least two pilots safely on the surface of Mars. If we obviously inquired more about the requirements for our contractor, and that is seen again on the next slide, where we figured out that not only did our space shuttle had to be reusable, but it also couldn't disassemble itself in mid-flight. The space lander had to survive an impact of about 12 like a 12-foot drop. Um, we were also able to find the weight of each of the landers, which were about 59 grams each. It overall, you couldn't use excessive materials. You had to get those approved by the contractors themselves. And there wasn't a size limit to how big or how small we could make the lander and the rover itself for our astronauts. So yeah.
Alrighty. Well, let's change it to me. I'm Matthew, the construction manager. This here is our final drawing. We have the top view where it was basically just our large plastic bag structure as the parachute. It measured at around 104.14 centimeters in length and was about 71 centimeters wide. Looking at the front view of the craft, it was about 58.42 centimeters tall. And then the side view, you can see that the pool noodles that we use that we'll discuss later were fed through the box. Next, we had to discuss the budget. So the materials that our team decided to use for this craft were the free tape and scissors, one pool noodle, 1 square foot sheet of bubble wrap, 4 plastic grocery bags, and our special request salvage item, which was a shoebox. The cost of the pool noodle was $5. The cost of the bubble wrap was $2. The plastic bags were $1. And because the shoebox was highly manufactured previously, the item cost went up to $5, totaling us at $13 for the project, which is $2 under the maximum budget of $15. You can see that the shoebox salvaged item was a Under Armour shoebox. We have our blue 56-inch long pool noodle, 4 plastic bags, our free items including a ruler, scissors, tape, 2 test eggs to make sure they fit, and our plastic bubble wrap. So basically, here's how the construction plan broke down. So first step was we had to gather all materials. Next, we had to use scissors to cut the 2 pool noodle holes on each side of the box. Next, we use scissors to cut pool noodles, or our plan was to cut the pool noodle into 4 10-inch sections and 2 5-inch sections. We will go into details later about how this was altered. Step 4 was to use scissors to cut an egg-shaped hole in the 2 10-inch pool noodle sections that will be fed through the box. Next, we have to poke holes on the top corner of each box to later feed plastic bags through. So we see here in step 6 where we fed the 2-inch section of pool noodles with egg-shaped holes through the box. Our second step, step 7 was to wrap the eggs in bubble wrap and fit them into holes in the pool noodle. However, this was also altered, and we'll go into more details about that later. Step 8 was to cut 2 plastic bags and feed them through opposite holes in the box, and we had to tie them off. That way they can be connected to the box. Our step 9 was to cut 1/4 of each remaining pool noodle lengthwise. So get rid of 1/4 of the pool noodle. And then we'll place those sections of the pool noodle, the bottom edge of the box, with the 2 remaining 10-inch going lengthwise and the 2 remaining 5-inch ones going widthwise. And we adhere them to the box using a lot of tape. Our construction plan part 2 included the parachute steps, where we cut 4 plastic bags along the sides until the base, and then we laid them next to each other on the table. We taped the 4 bags together along the edges on both sides to contribute to structural integrity. And we cut the handles in half and fed them through the small holes in the top corners and tied them off and reinforced them with tape.
Hello, I'm Julian Barrios. I'm one of this team's project construction managers, and today I'll be going in a little bit about our construction plan. So while we had an original design for our shuttle, the main change that we made was adding a hatch on top, so it would make pilot transfer from in and out of the shuttle easier. The plastic bags were also an influential part in this because they were fed through the box and it made it hard to open the lid to actually access the egg pilots. So we decided to make that change so the hatch was easy in order to access the eggs. So the pool noodles that we did use that were originally 10 inches fed through the shoebox were made 2 inches longer in order to accommodate for the rest of the structure. And the bubble wrap was used as a seat belt, which was taped around the outside diameter of the interior pool noodles in order to keep the eggs in place, just in case that they would fly out on excessive force.
Hi, I'm Logan Stroud, and I was also an assistant construction manager, and I was the manager as well. So as you can see here, these are our top front and side views of our lander. In the front view, you can see very specifically the alteration that we made to add a hatch to the lid of the box or the lander. As Julian previously mentioned, the plastic bags or a parachute essentially shut the lid shut, which I get helped in a few different ways because we didn't need to worry about the top of the lander opening up while struggling to access it. So the hatch in the top was definitely a necessary alteration. And as you can see, we changed the pool noodles on the side of the on the side of the lander. The distances just varied in that. And as you can see, the holes around the pool noodles were cut a little bit smaller than the actual pool noodle. So it would be a little bit more secure and we didn't have to use any other alterations or any external additions to keep them in place.
So here's our official lander vehicle test plan sheet, also known as our DD250. Here we can see an official record of not only the measurements of our final design, but also the time it took in order to place and unload our test pilots. As you can see, the more times that we put our design to the test, our loading times got faster. And this was partly due not only to just gaining experience over time, just taking the pilots in and out, but also thankfully due to the hatch design that we decided to implement into our final design.
It's worthy to note that the lander passed all tests.
Our 3 test videos. As you can see, I was the test manager. I had to lift it over the landing pad and at least hold some of the parachute so it would not fail and it wouldn't deploy properly. So I just had to have a hand on the parachute to make sure that some air would get under it as soon as we dropped it. But loading the lander was very accessible due to the lid and the quick seatbelt method that we did with the bubble wrap around the inner diameter of each pool noodle on the inside of the box really made it easy to strap in our astronauts and led to a speedy unload and load times.
Okay, so here are the videos. Test 1. Test 2. And since both tests were success, here's our third and final drop for fun.
So as you can see, the parachute was definitely a very influential part of our design. It deployed perfectly and did a great bit of carrying the weight of the box. I mean, I don't think it could have done any better of a job. Credit to Diego for coming up with that design.
All right, trying to switch slides here. There we go.
Yeah, so our design proved to be actually very successful. As Logan and Matthew were saying earlier, they succeeded in all of our slide testing. And we even made it to the 3rd floor test, which wasn't for record, but for bragging rights, essentially. Here in the photos, you can see that on both official tests, both of our pilots were undamaged and succeeded in successfully making it onto the landing pad.
So for our final takeaways and comments and concerns, our team were able to brainstorm and design a capable and safely secure the 2 astronauts through suspended floaties that were strapped in safely with thin layers of bubble wrap and were encased within the box. There was also the flap, again, for easy boarding and unboarding. The parachute itself consisted of 4 plastic bags, which was a design prerogative that we took there and then also. Originally, we were planning for just 2, but we decided to opt for 4 bags, and we taped them together to form one long cohesive sheet, which, they were all tied nicely at the corners of each of our boxes. They were also simultaneously preventing the box from opening as it glided down. And the assembly process itself went smoothly, while the project manager and myself oversaw the construction of the plastic parachutes. The test and construction managers both swiftly assembled the main shuttle. Soon after each of the parts were complete, all of us came together for the assembly of the individual parts as a whole, introducing new design ideas like the flap and the holes that allowed the parachute to be threaded through in such a way that it prevented the box from opening mid-flight. The results in the end spoke for themselves. Our shuttle not only performed not just the 2 required 12-foot drops without any significant damage to the vessel and with no damage at all to our astronauts, but it also in fact worked so well that we were able to test it against a job that was almost 3 times that original length. The shuttle and the astronauts survived those falls still. And if we were to do any form of redesign, it would just be for an optimal smaller size, maybe optimize the space that like the time that it took for the assembly or for anything like that, because overall the design worked as intended. And as of date, there is no significant change to the design our team can think of. And I think overall that our shuttle just showed our progress as a team. And I think we are all collectively proud of the shuttle. And it's just a reflection of our creativity, craftsmanship, and successful teamwork. Thank you for coming along in this journey and watching our presentation. And that is our space shuttle.
All right, thank you.
There you go.